Hey students, this is lesson 133. In this lesson, we're going to formalize the equation for a linear situation and learn how to look at a graph to figure out those different parts of the equation. So we're talking about the kinds of equations we've been writing, and they look like that. We're going to fill in this table here in class. I'm going to just start with this problem here. And what we're going to try and do is connect the different parts of the equation to the graph. All right? Go ahead and check this cartoon out. Pause right now and read it. And then we'll talk about it here. So what do you think? Is Maya correct? How can she know the point 0, -1 will be on the graph? All right? And so just think about that. The point 0, 1, well, if x is 0, and you do 3 times 0 minus 1, well, what's 3 times 0? That's 0, and 0 minus 1 is equal to -1. So if she knows the point, the value 0 and -1 are solutions to that equation, then she knows that that will be a point on the graph. Okay? And then it says, how might you use the slope to determine other points on the graph, like Darnell suggests? So we know the point 0, 1, that's on there. There it is. And we also know that the slope is 3. That's this part of the equation right there, 3. And the slope of 3 means that the rise is 3, the run is 1, because 3 divided by 1 equals 3. So that means if I go up, let's put a little dots here, up 3 and over 1, there's going to be another point on the graph. All right, and then I can just draw a line through there, and I really only need 2 points to create a line. You might want to put one more just to make sure you get a straight line. So I can also go back 1 and then down 3, and I'll get the same situation there. And then just draw a line through there, and you got the graph. All right. How many points would you need to plot? Well, you just need 2 points. 2 points determine a straight line. All right. So we're going to go ahead and go to number 3 on the next page. And it says for each graph below, determine the coordinate 0p for the y-intercept. Now the y-intercept is a place where it crosses the y-axis. So you want to look on the y-axis always. And so we'll just do part A here. For the first graph, we're talking about this point right here. And the coordinates for that point are 0. They're always 0 to start with because on the x-axis you're at 0. And then on the y-axis we're at -5. So that's the y-intercept for that one. So we'll fill that in down. We'll just fill that in on the graph. And then it says for number 4, it says for the graphs in exercise 3, determine the slope, the rise over run. So to do that, I'm going to pick 2 points on here that look like they cross on this line, and it looks like it's going like that. So just pick 2 of those, and my rise and my run, I'm actually decreasing. So my run is 1 and my drop, it's actually dropping, so my rise is -1. So I'm going to do rise divided by run, that's -1 divided by 1, which is -1. Right? And then number 5 says use the y-intercepts from exercise 3 and the slopes from exercise 4 to write the equation. Now remember, here's the deal, here's the equation form. The slope goes where the m is, the coefficient is the slope, and the y-intercept is the b part, or the constant term. So my equation for A is going to be -1x plus, and my y-intercept was -5, so plus -5. Now I can simplify that a little. When I multiply -1 times x, that's the same as -x, and adding -5 is the same as subtracting 5. So that That looks a little better there. All right, I'm going to ask that you try a couple of these, see if you can do that. You can do 1, 2, whatever. At least try one of them. If you want to pause now and do that, maybe do B. If you did it correctly, you should have that the y-intercept is the point 0, -8. And then doing rise over run, you maybe use this point here and you went up 5 over 1. So you got a slope of 5, and the equation then would be y equals 5x minus 8. All right. We're going to go to the next page and do one of the problems on number 6. It says for each equation, use a grid to plot the y-intercept 0b, then use the slope to plot 2 more points. Connect the points to form graph of the equation. So we're going to look at the equation, and remember y equals mx plus b is our form, and that part right there is the y-intercept, at least the y value of the y-intercept. So looking at this, if it was written as addition, it would be 3x plus -1. So the y-intercept is, for A, is 0, -1. We're going to plot that. That's right here. Now our slope is 3, and our slope, which is the end part of the equation, is 3. And if I want to write that as a ratio, rise over 1, that would be 3 over 1, where 3 is my rise. So I'm going to go up 3 and over 1, or 1 to the right. So to plot another point, I'm going to go up 3 over 1, and I'll do that a couple times to get 2 points. And I'm just going to draw the line in there. So that'll look something like that. And go ahead, you try B, and you can pause right now and check back in a second and see if you did it right. All right, if you did that correct, you should have some dots that look like that on part B, where the y-intercept is 0, 4, and you're going up 1 over 2 to get more points on that from the slope. All right, if you want to try a couple more, maybe you want to do part, maybe do C from each of the 2 problems we just did, number 3 and number 6, and we'll check those next time we meet in class.